Welcome to the Explainer. Today we are peeling back the layers of your computer to see what really happens when you do something as simple as clicking your mouse. We're going to go on a journey from that single click on your screen all the way down to the very heart of the operating system.
Okay, let's just dive right in. Whether you're a person who right-clicks to create a new folder, or you're someone who likes to open up a terminal and type a command like mkdir, the goal is exactly the same. You are telling your computer to do something. But how does it actually understand that? And maybe more importantly, how does it do it safely without risking your entire system?
To get our heads around that, we first need to talk about the two fundamental ways we communicate with our operating systems. You can think of them as two different languages that both get you the same result.
So first you've got the GUI, the graphical user interface. This is the world most of us live in. Desktops, icons, menus, the whole shebang. It's visual, it's intuitive, but then you have the CLI, the command line interface. This is that text-based window where you type in direct, powerful commands. But here's the key. Both of these are just different front doors to the exact same house.
Now this is where it gets really interesting. Behind those interfaces, your operating system keeps everything separated for safety. It's basically operating in two completely distinct worlds, and each one has its own rules and its own powers.
What you're looking at here is the fundamental trade-off that's at the very heart of your computer. On one side, you've got this safe but kind of limited world where all your apps live. That's called user mode. And on the other side, you have the all-powerful but super risky world where the core of the OS runs, and that's kernel mode. This separation is absolutely crucial for keeping your computer stable.
Your web browser, your video games, your word processor, pretty much everything you use runs in this user mode. A good way to think of it is like a protective sandbox. If one of your apps has a bug and crashes, it's not going to take down the whole system. The OS just contains the mess, keeping the important stuff safe and sound.
Now, kernel mode, that's the main control room. It has total, direct, unlimited access to everything. Your memory, your processor, your hard drive, you name it. This is where the most critical, low-level tasks get handled. But with all that power comes some serious risk. If anything goes wrong in kernel mode, your entire system can grind to a halt.
So hold on a second. If all our day-to-day apps are stuck in this safe, limited user mode, but all the powerful tools to actually do things, like, say, save a file, are in the high-stakes kernel mode, well, how do they even communicate? How does an app ask for something it's not allowed to do itself?
There's got to be some kind of secure bridge, right? An official, vetted process for a program to ask the operating system to do a special task for it. You can't just let any old program wander into the main control room and start flipping switches.
And this is the brilliant solution. It's called a system call. It is the formal, programmatic way for an application to request a service from the kernel. It's kind of like your app has to fill out an official government form in triplicate just to ask the control room to perform one specific authorized action.
So, when an application makes one of these system calls, something really incredible happens. The processor does what's called a context switch. It literally, for a split second, shifts from that limited user mode into the all-powerful kernel mode, does the single task it was asked to do, and then immediately switches right back to the safety of user mode.
Okay, so you might be wondering, how often is this actually happening? Well, to really get a sense of the scale here, let's break down a super simple task we all do, copying a file. You'd probably guess it's, one or two steps? But the reality is way, way more complex. Okay, just to get started, the system needs the file names. That involves a system call to write a prompt on your screen. Then another system call to read what you type on the keyboard. Then a system call to open the original file. Then another system call to create the new file. And then you get into a whole loop of system calls, one to read a little piece of data, one to write that little piece of data, over and over and over again until the job is done. And believe it or not, that's not even the full list. What if the file doesn't exist? You need a system call to show an error message. When it's finally finished, you need a system call to close the file, and probably another one to write success on the screen. Literally every single interaction with your computer's hardware requires one of these formal requests.
This isn't some rare event we're talking about. This little dance between user mode and kernel mode is happening constantly. We're talking thousands of these system calls firing off every single second your computer is on, orchestrating everything you see and all the stuff you don't.
All right, let's tie this all together.
Let's trace that full journey one last time, from your simple click, all the way down into the computer's core, and then all the way back out again.
It all begins with you, with your action in an application, and that app is running safely inside user mode.
So the program understands what you want, but it doesn't have the permission to actually touch the hard drive itself.
So what does it do? It bundles up your request into one of those formal system calls and sends it off to the only part of the system that can actually help, the kernel.
And instantly, the processor flips that switch. It performs a context switch, elevating its own privileges to enter the super powerful kernel mode.
And now, in kernel mode, with direct access to all the hardware, the operating system carries out the command, telling the physical disk drive to save your data.
And in the second the job is done, it performs another context switch, dropping its privileges and returning right back to the safety of user mode, letting your application know that everything's good to go. This whole round trip is completely invisible and happens in a tiny fraction of a second.
So the next time you click, or you drag, or you type anything at all on your computer, just take a second to remember that there is this invisible, incredibly complex, and really elegant dance of system calls that's making it all possible. What looks to you like one simple action is actually a lightning-fast conversation between your apps and the very core of your machine.